Now let us move to third type of reaction, that is displacement reaction. Displacement reaction says that one of the more reactive element displaces the less reactive element. For example, if we consider the reaction when we are having iron nail which is dipped in copper sulfate solution, the iron which is more reactive displaces copper from copper sulfate, and that copper now come and get deposit on the surface of iron nail. Originally iron nail was like this, and now the copper has been deposited on this iron nail by dipping this iron nail in copper sulfate solution, because iron is more reactive. So here the displacement reaction takes place, and iron which is more reactive than copper displaces copper from copper sulfate solution. So this is how the reaction takes place. Similarly, when we perform the activity by adding iron in copper sulfate, we observe that the reaction takes place and this copper sulfate changes into copper and iron gets oxidized to iron sulfate. So this is one of the displacement reaction where iron which is more reactive displaces copper and it takes its place. That's why we call it as displacement reaction. It takes its place and it eliminates copper. So copper gets deposited on this iron nail. This is how this displacement reaction takes place. So in this reaction we observe that iron either has been removed completely, the element copper, and copper starts depositing. So we are having a new solution, that is iron sulfate along with the formation of copper. Similarly, some other reactions, zinc when react with copper sulfate, zinc which is more reactive displaces copper from copper sulfate to form zinc sulfate. Lead when react with copper chloride, lead is more reactive than copper and this lead displaces copper and it takes its place, we get lead chloride. So here in these reactions we observe that one of the metal displaces another metal and it takes its place. We call such reaction as displacement reaction. Now we will talk about the double displacement reaction. Double displacement reaction is involving the exchange of ions between two salts. So suppose I am having one solution as sodium sulfate and another solution as barium chloride. When we add these two, when we mix these two, sodium sulfate and barium chloride, we observe that the sodium goes with chloride and barium goes with sulfate. So we can say that it is intermixing or exchange of ions takes place between these two salts, and finally we observe a precipitate of barium sulfate has been formed, and where the double displacement takes place results in the formation of a precipitate. We call such reactions as precipitation reaction also. So most of the double displacement reactions are precipitation reactions that involves the formation of precipitate. So where sodium sulfate and barium chloride has been mixed, sodium will go with chlorine and barium will come with sulfate, and finally we will get a precipitate of this barium sulfate which is insoluble along with the formation of sodium chloride. So it results in the formation of a precipitate, that is barium sulfate, and thus we call it as precipitation reaction also. So when we define double displacement, we say that it includes the exchange of ions. And last type is oxidation and reduction. And the reaction is known as redox reaction, where oxidation and reduction both takes place simultaneously. So let us discuss first what is oxidation, what is reduction. So oxidation means addition of oxygen. So for example, I am having copper powder and I just burned it on this burner in tripod stand. In presence of oxygen, this copper changes into copper oxide. We can say that oxygen has been added into copper and thus copper undergo oxidation. So what is oxidation? Oxidation is addition of oxygen. So what is reduction? Reduction is reverse of oxidation. We can say the removal of oxygen is reduction. Similarly, when we add hydrogen to it, addition of hydrogen is reduction. Addition of hydrogen is reduction and removal of hydrogen is oxidation. So now we are having two definitions of oxidation reduction. In terms of oxygen, addition of oxygen is oxidation, removal of oxygen is reduction, and removal of hydrogen is oxidation, addition of hydrogen is reduction. So let us discuss about the second example. Addition of hydrogen takes place to this copper oxide and thus it reduces into copper along with water. So copper includes the removal of oxygen, and thus we can say copper undergo reduction. At the same time, we can say that oxygen combines with hydrogen, so we can say that hydrogen undergo oxidation. So we can say if any of the substance gains oxygen, it's said to be oxidized, and if any substance loses oxygen, we call the substance to undergo reduction. So finally, we can say that oxidation and reduction are reverse of each other, and in any of the reaction, when both oxidation and reduction takes place, we call such reactions as oxidation reduction reaction or redox reaction. For example, in this case, this copper oxide undergo reduction into copper as it includes the loss of oxygen, and hydrogen undergo oxidation as it includes the addition of oxygen. So this whole reaction is known as oxidation reduction reaction or redox reaction. Similarly, we can observe this oxidation in our day-to-day life as the corrosion. When we wear gold or silver, we observe that this after some time silver becomes a little bit black. Why this is so? This is because the silver starts reacting with the impurities or gaseous substances present in atmosphere. Similarly, iron undergo oxidation to form rust. So this is nothing but the slow eating of metals in presence of oxygen or moisture to form the oxidized product. So if I ask you what corrosion is, we can say when metal is attacked by any substance around it in terms of moisture, oxygen, acid, salts, it starts corroding. Its surface starts deteriorating, and we call the process as corrosion. The less reactive metal will not corrode so fastly, whereas the more reactive metals will corrode easily. We know that gold is less reactive and thus it does not corrode easily, and we can see the shine on the gold substances easily. Whereas when we talk about iron, which is more reactive, so it gets react with or corrode with the atmospheric oxygen and moisture to form rust. So corrosion in case of iron is known as rusting. It forms rust in the form of, the formula is Fe2O3 with some molecule of water. The water molecule number can vary, depends on the amount of moisture present in atmosphere. So what is the harm of corrosion? It causes damage to our car bodies, to bridges, iron railings, almirahs, ships and all other objects which are made up of metal and can easily prone to corrosion or oxidation or rusting. So it is a big hazard in the case of iron which causes rusting, and it's day by day deteriorating the surface of metal. Finally, we'll talk about rancidity. Sometimes when we eat some oil or fatty substances food, we observe that there is some bad smell comes out from that food. But if we purchase the same chips or food item from market which is also having oil in it, we do not get that foul smell from that packet of chips. Why this is so? The reason is the fats and oils, if they are not properly stored, containing food item undergo oxidation easily and they form certain substances which causes some bad smell, and we are not able to eat those substances. We call this oxidation of fat or oil as rancidity. So basically rancidity is nothing but the oxidation of fat and oil, and they become rancid. It means their smell and taste changes. Usually the substances are added to prevent the rancidity are mostly antioxidants, means which doesn't allow the food particle or fats or oils to undergo oxidation. Even we can protect them from rancidity by keeping it in airtight container or in refrigerator, or even by passing nitrogen gas like in the packets of chips what we purchase it from the market. So we can keep our food in airtight container to slow down the process of oxidation, or we can say the slow down the process of rancidity also. So these are certain preventive measures by which we can protect our food from being rancid. So this is all about the chapter. Now let us discuss certain questions. So question is, which of the following is not a physical change? So one which is not a physical change, here is the combustion of LPG. So option D is the correct answer, because in first, second and third it only includes the change in state, whereas in third case we observe that it includes the formation of new substance. So combustion is a chemical change, it is not a physical change. So option D is correct. There is an equation which contains equal number of atoms of each element on both the sides. What we call that equation? A balanced equation, or an unbalanced equation, or a chemical equation, or all of the above. If I am saying that it has equal number of atoms of each element on both the sides, we call that it as balanced equation. Yes, the option 1 is correct. So we call it as balanced equation, which is not a physical change. So let us discuss another. Physical change nahi hai means evaporation of petrol. It evaporates, changes its state, physical state only. Burning of liquefied petroleum gas. Burning means we are just converting into the oxidized form. Heating of iron to red hot, that is also physical change. Sublimation is also physical change. So in this case, option B is correct. What happens when dilute sulfuric hydrochloric acid is added to iron fillings? So when iron is added, Fe plus HCl, we get iron chloride along with hydrogen gas. So hydrogen gas and iron chloride, I can see the option 1. So option A is correct. And last question is, in the given equation, what does this X stands for? So this is for you as a homework. Just try to balance the equation and find out what is the correct answer. So this all about is the chapter. Thank you so much.